Okay, welcome to another Orbiter 2010 video. And in this video I'm going to go from the moon back to the Earth. I've done this flight a couple times using TransX. So this time I'm going to use LunarTransferMFD. First thing I'll note is that I'm using the landed at Brighton Beach scenario. Again, I've used this one a couple of times. This comes default with the XR2 installation. So first thing I'm going to do is open external MFD, and that way I can get a good large MFD that will make it easier to see in the video playback. I also want to mention that I'm not actually going to land once I get back to Earth. And the reason for that is because I've actually done this video once already and ran into a couple of problems. But also just mainly due to the fact that it just takes so long to land. It adds an additional 30 minutes or so to these videos. It just takes a really long time. And I've already got several videos on my YouTube channel where I show different landings. So let's open LunarTransferMFD. And this is kind of what it looks like by default. First thing I need to do is press PRG to bring up the program menu. And the way we navigate Lunar Transfer is pretty simple. This NXT, you can probably figure out that that means next, is a next item. And PRV is previous, as in previous item. So I'm going to go to where program config is highlighted and underlined and press plus. Actually, I can press plus, minus, or I think I can even press set. But I'll just hit set, or rather plus. I'm going to go down to auto exe and turn that on. Now I'll press PRG to get back to the main menu. And I'm going to come down here to program TEI, the Trans Earth Injection Program. Press plus there. And I'm going to come here to FST, change this from launch to TEI. And you'll notice there's no information down here, but when I press EXE, all that gets filled in. All this information is calculated automatically, and the way I can change the information that is calculated is by making adjustments to these parameters over here. The first thing I want to do is I want to change the heading from 45 degrees to 90 degrees, and that just means when I get back to Earth I want to be coming back with the normal inclination of, coming out of the west and heading toward the east, and that would just be a normal 90-degree heading. So I'm going to change the adjustment to 100 and press plus plus. That'll take it to 55, 65, 75, 85. Now I can change the adjustment to 10 and bring that up to 90. I'm also going to change the periapsis. Instead of coming back with a periapsis of 60 kilometers, which would be what you would want if you were going to try to do atmospheric braking, I'm going to change that to a more normal altitude that I would orbit at for coming back to the Earth and then planning on landing. I don't want to dock with the International Space Station, so I don't want to altitude of 300 plus kilometers. I want to plan on landing eventually, so I just need an altitude of about 185 kilometers. Change the adjustment to 10, and something like that should be good. And the last thing I want to change is the amount of time that it's going to take me to go from the moon back to the Earth. I'm going to start by setting this to 96 hours, and then I'll adjust it from there. But the reason I'm starting with 96 hours is because I want to have a fairly low energy ejection from the moon so that I don't need a lot of fuel. This is a pretty typical amount of time to go from the moon to the Earth, roughly, 3-4 days. But now what I want to adjust is I want to plan on coming back to the Earth and being at a specific point around the Earth when I get there. I don't just want to arrive wherever. According to LunarTransferMFD, my current arrival longitude is going to be 22.5 degrees east. Now I have no idea where that's at. If I press Control F4, bring up another external MFD, open map, reference the Earth, and let me target, let's go with wide awake. I can see that wide awake has a longitude of 14.43 degrees west. Now if you're going to land at wide awake, I don't want to arrive, I don't want to show up at Earth when my lowest point of orbit, my periapsis, is exactly at this point, because then, I can't eliminate all that velocity and land immediately. I need time. So I want to arrive back at Earth when I'm at least 90 degrees west of wide awake. And I think I would actually prefer if I were like 180 degrees west, which would be, all the way around to the other side of the planet. So I'm going to plan on arriving with a longitude of 175 degrees east. And the way I change the longitude is by changing the amount of time that I plan on being in space between the moon and the Earth. Because the Earth is going to rotate the whole time I'm floating through space. So the more, depending on how much time I'm in space will depend on, how many rotations there are between the time I leave the moon and the time I get back to Earth. So if I change the time, start taking away a little bit of time, I can see the longitudes moving. Take away a little more time, it's 52 degrees east. Take away a little more time, 68 degrees east, and so on. And if I keep going, I can get to this point where I'm at about 175 degrees east, and that's going to be about 86 hours instead of 96. Still low energy, which is fine. And that should put me about halfway around the Earth when I get there. Okay. So let me go ahead and close out Map MFD. I have the information that I need from this part of LunarTransferMFD. So now I can come over here to FST, change TEI to launch. And this tells me what my heading needs to be in order to get the orbital parameters that I established prior. So I need to lift up off the pad, rotate to 262.77 degrees, and head out that way. Now, to help me keep my flight up off the moon correct, to help me keep my relative inclination correct, I can start a line plane MFD, and I can use this information here. Press ELS, and this gives me a dialog box to put in the ecliptic inclination and the longitude of the ascending node. That's right there. Oops. So I type in 137.23 space, 143.72 enter, and that gives me this information here. So as I lift up off the pad and head out, Align Plane MFD will let me know if I'm on track or not. So let's go ahead and do this. Let's take off and head out. Start the APU. I'm going to get rid of this scram fuel. I don't need it, so it's just a waste of weight.
Warning, fuel dump. Warning, scram fuel low. Warning, scram fuel depleted.
Hover doors are already open. Radiator is extended. Of course, the landing gear is down. Go ahead and leave the APU on for now, because I'll need to retract the gear after liftoff. So I'm just going to lift off, rotate to 262, call it 0.8, and then we'll head out.
Wheels up.
Go ahead and raise that landing gear.
Gear up. Gear up and locked.
Okay, we've already got RCS mode set to rotation. So I can start rotating toward 262.8. Should be about right there. Now I can go to full main engines. Pitch up just a couple degrees. I don't want to pitch up very much at all. And then immediately turn off the hover engines and close the hover doors. Now I can turn off the APU and keep an eye on the relative inclination over here. While that's establishing that, I will bring up orbitMFD so I can keep an eye on my ascent. Watching my relative inclination. Ideally, it should be 0.00. Keeping an eye on my apoapsis. Don't want it to get much above, say, 30. And we'll go with that. Got a 0.00 relative inclination. Apoapsis got a little bit higher than I really wanted it, but that's okay, it's fine. So I don't need the Align Plane MFD anymore. So I'll go ahead and bring up orbit on this side. Close this out. Since my plane alignment's fine, I don't need to worry about that. But I do need to possibly circularize my orbit. If I want to do that, that's coming up in about 680 seconds. But it's possible that I'll need to do my TEI burn first, and if that's the case, then I don't need to circularize. So let's find out when I need to do the TEI burn. Over here in LunarTransferMFD, with the launch set, I can press plus to change that to TEI, hit execute, and this is telling me that my TEI burn is not for 2,150 seconds. So I'm definitely going to reach apoapsis first. And in fact, I'll probably even, I'll get pretty far over that way, so I definitely need to circularize the orbit. So let's go ahead and warp ahead to apoapsis, or close to it. Okay, coming up on apoapsis here in 10 seconds. Let's go ahead and circularize the orbit pretty well. Okay.
Translation.
Certainly good enough. Okay, the orbit is basically circular. So now the only thing I need to do is the lunar transfer burn. One of the nice things about this particular MFD is that it will handle the entire burn for you. Now, some people may not actually like that because they may think it's too automated. For my personal taste, I've done the Earth to Moon and Moon to Earth so many times that I don't feel like I need to do everything manually anymore. I know all the steps, so I don't have a problem with a little bit of automation. But the burn's coming up in 1,430 seconds. What I need to do, if I want to do this automatically, is press DV, and then for auto burn here, execute. And now I can see that the state is waiting, and the time, is 1,400 seconds. I can also just warp time ahead just by, pressing T. And then the cool thing about LunarTransferMFD is that when it gets closer to the time to the burn, it will automatically shut off time warp for you so you don't overshoot or anything like that. So I'll show you how that works. I'll go out to 1,000, and it'll automatically back down to 100, and then it'll automatically back down to 10 here, like it just did. Now it's getting aligned. And the burn's coming up in 60 seconds. Burning. You can see orbit MFD, and there it is. LunarTransferMFD is finished executing the burn. So we are now on our way back to Earth. So now what I'm going to do is reference the Earth from orbit MFD. And now I'm going to accelerate out to about 10,000x so I can close the distance between the Earth and the Moon more quickly. But just to give us something better to look at, go ahead and go to the external view here. Out to 1,000x, pulling away from the Moon. And we'll go to 10,000x for a second. Alright, let's see where we're at. I'm going to go ahead and get close enough to the Earth so that the Earth is the primary gravitational influence, and that'll happen when G changes from red to green when this reaches 0.5. Okay, so now we are within we're close enough to the Earth that the Earth is the primary gravitational source, so I can now use prograde so I can face Earth just to see where we're at. Okay. And according to orbitMFD, our periapsis back at Earth is going to be negative 3,600 kilometers, but I know that this is wrong just due to the math model that orbitMFD uses, as I've discussed in other videos. This is just wrong. It'll get more accurate as we get in closer. I do need to think about a mid-course correction, and that's something that LunarTransferMFD will do for us. So I'll press DV to come back over to this screen, and I'll press plus here to change this from TEI to TECC, which is something like trans-Earth course correction. I think I'm going to get a little closer to Earth first, so let me go ahead and warp out to 0.60. I just want to make sure I'm far enough inside of Earth's gravitational influence to have a good mid-course correction. And we'll go with that. So I'll press EXE to bring up this information. And if I needed to make any adjustments to the longitude, I could do that now by coming over to PET and changing the amount of time left to get back to Earth, but this is all fine just how it is right now. So with all of this set, press DV again, then for the auto burn I'll execute. That's going to happen in 270 seconds. And again, I can accelerate time, and lunar transfer will automatically slow us down so we don't overshoot. And it does the burn for us. Very small burn. Okay, go to prograde. And now we can warp ahead to we're much closer to Earth. can go ahead and close out LunarTransferMFD. Done with that.
Rotation.
Warp until I'm closer. And about the final thing we want to do here is to just do the deceleration burn at periapsis. But I do want to take a look here in just a moment to see exactly where we're at on Earth as we're coming into periapsis, just to make sure that our navigation was all good. That should be close enough, so let's bring up an external MFD. Bring up map, reference the Earth. And we'll want to target wide awake. So as we're coming around to periapsis, ideally we should be about halfway around the planet when we get to the periapsis point. That would allow us to do our deceleration burn and land right away. I'm not going to land again just because it takes too long. It adds too much extra time to these videos. So let's go ahead and accelerate out to periapsis. Getting pretty close. And it looks like our navigation was spot on. We're going to be pretty much exactly halfway around. So we'll go retrograde here. And at about 80 seconds, I believe, is a good time to start the deceleration burn when you're coming back from the moon. But I don't actually want to be in the exact retrograde position. I want to be rotated out just a little bit. That'll keep my periapsis, or rather my apoapsis, my periapsis. It'll keep my periapsis from climbing. Let's go ahead and start the burn. As I'm doing this burn, if I control my inward and outward, I can control how much my periapsis is at. So right now it's holding at 189.5. But as I actually pass the point of the periapsis, I'll need to start rotating inward slightly. See, now the periapsis is going down a little bit. So if I rotate in just a little bit more, see, now the periapsis just went up from 189.4 to 189.5, 189.6. So I can rotate backwards, or more back towards center a little bit. Now it's going back down 189.6, 189.5. So we'll rotate out a little bit again. Or rotate in. that's just how you can control your periapsis. If you just put it on retrograde and hold it, then you won't be able to control your periapsis quite right. Coming up to the end of the burn. Okay. I can continue to circularize the orbit, but I want to make sure my periapsis doesn't keep going down. I'm just trying to remember if I need to rotate in a lot or if I need to rotate out a lot. Having some bad frame rate at the moment because I'm recording. Okay, so that's continuing to go down. You can see the periapsis is going up and the APA is going down, so we're getting more circular, which is what we want. And we are very circular at this point, so let's go with that. Okay. So that is going to be the end of this video. We went from the moon back to the Earth using LunarTransferMFD. We handled the main burn with LunarTransferMFD, was completely automated. We handled the mid-course correction with LunarTransferMFD, that was also completely automated. The only thing I did do manually was the deceleration burn here at Earth. And I believe, actually I know, that LunarTransferMFD will even handle some aspect of that with actually maybe it won't. It'll do the circularization when you get to the moon. That's the LOI program, lunar orbit insertion. But it doesn't look like it actually has a program for Earth, so you do have to do that part manually, it looks like. Okay, so now if we actually wanted to land at Wide Awake, obviously it would just be, normal stuff, getting into alignment with Wide Awake and then bringing down the periapsis and going around and landing. But again, that part just adds way too much time to these videos. So hopefully you got something out of this video, maybe learned a little bit about how to use LunarTransferMFD. If you liked this video, leave a comment down below, let me know what you thought. If you'd like maybe more information on this MFD, let me know. Maybe I'll do some other video and show maybe a little bit more with this MFD, some different things that you can do with it. So I'm going to go to where program config is highlighted and underlined and press plus. Actually, I could press plus, minus, or I think I can even press set. It'll just hit set, or rather plus. I'm going to go down to auto exe and turn that on. Now I'll press PRG to get back to the main menu. And I'm going to come down here to program TEI, the Trans Earth Injection Program. Press plus there. So first thing we're going to do is open external MFD, And that way I can get a good large MFD that'll make it easier to see in the video playback. I also want to mention that I'm not actually going to land once I get back to Earth. And the reason for that is because I've actually done this video once already and ran into a couple of problems. But also, just mainly due to the fact that it just takes so long to land. It adds an additional 30 minutes or so to these videos. It just takes a really long time. And I've already got several videos. And I'm going to come here to FST, change this from launch to TEI. And you'll notice there's no information down here, but when I press EXE, all that gets filled in. All this information is calculated automatically, and the way I can change the information that is calculated is by making adjustments to these parameters over here. The first thing I want to do is I want to change the head videos on my YouTube channel where I show different landings. So let's open LunarTransferMFD, and this is kind of what it looks like by default. First thing I need to do is press PRG to bring up the program menu, and the way we navigate Lunar Transfer is pretty simple. This NXT, you can probably figure out that that means next, as in next item. And PRV is previous, as in previous item. Okay, welcome to another Orbiter 2010 video. And in this video I'm going to go from the moon back to the Earth. I've done this flight a couple times using TransX. So this time I'm going to use LunarTransferMFD. First thing I'll note is that I'm using the landed at Brighton Beach scenario. Again, I've used this one a couple of times. This comes default with the XR2 installation.